Welcome back. Today we are going to see another interesting video on how to find crystal point groups. In this video we will see a master key as a flow sheet by using a different defining symmetry of the crystal system. In this video we are going to see how to determine the point group symmetry. In this video also we are going to see how a sequential elimination method helps to find a point groups among that 32 types of point groups. Here we use the top-down method. It's a very simple method. By using yes and yes or no, we can eliminate the rest of the point groups from the which we are interested. Before starting the identifying that method, we should recollect the defining symmetry of different crystal system. We are repeatedly saying the importance of defining symmetry. In this video also we will see again how the defining symmetry helps us to identify the different point groups. Just for a recollection, the defining symmetry for Q is 4x of threefold symmetry, and for tetragonal it is only one fourfold, and orthorhombic is a 3 two-fold axis, or it may have mirror plane, and hexagonal is 1x of six-fold symmetry. Rhomboidal is only one three-fold axis. Monoclinic is only one two-fold axis or mirror plane. Triclinic system is not contain any defining symmetry. Fundamental, one should remember to define a crystal system. The crystal systems are defined by the defining symmetry, not by the unit cell. We have seen this in the earlier lecture. Here the defining symmetry, how it is going to help us to know the possible point groups, we will see. This is a quick guide to spotting a right symmetry. Here we will use the defining symmetry to diagnose what point groups on what system it is. For example, first we have to start with the six-fold symmetry. The six-fold symmetry is only possible in hexagonal system. So first we have to check, does it have a six-fold symmetry? If the answer is yes, then straightforward answer that the crystal system are formed from these possible point groups like 6 by m, 6 to 2, or 6 mm, 6 by m, or 2 by m, and 2 by m. So these are the possible point groups symmetry from six-fold axis of symmetry. So by this single method, by identifying the six-fold symmetry in the crystal, we could able to say this is the only possible point groups from that particular crystal system. If suppose the answer is no, that means the crystal is not having six-fold symmetry, then we have to go for a next identification, in which we have to check the next rotation of symmetry, like threefold symmetry, because the threefold symmetry helps us to diagnose that trigonal and cubic. So whether the presence of threefold, how many threefold? Because the trigonal have only one such axis, whereas the cubic must have more than one. So the next question comes that does it have more than one threefold axis? If answer is yes, then possibly it may be a cubic system, and we also should verify with the 4 axis of threefold symmetry, because that is a defining symmetry for cube. Similarly, if not having more than one, then it must be a trigonal, and what are the two other point groups of hexagonal. So this isolates from the cubic system. So one should check first 6-fold, then 3-fold. Then next possible one, we can go with the 4-fold symmetry, in which this straightforward we can get the answer that only one 4-fold symmetry will get from the tetragonal. So if the answer is yes, as a crystal system, the crystal model which you hold, if it is does 4-fold symmetry, then these are the possible point groups from that particular system. And suppose you don't have 6-fold or 3-fold or 4-fold, then we have to go further checking to find whether this particular crystal have any 2-fold axis. Here again, how many 2-fold? Because 2-fold we have in the monoclinic as well as in the orthorhombic. So does it have 3 perpendicular 2-fold axis? If the answer is yes, then it is a straightforward, it is a orthorhombic, and these are the 2 possible point groups we will get from that crystal. If again there is no 3 perpendicular 2-fold axis, then there is another defining symmetry for orthorhombic is a mirror plane. You have to check that also. So does it have only one 2-fold axis? Because this able to distinguish monoclinic, because monoclinic have only one 2-fold axis. So this helps to identify from orthorhombic as well as from the tetragonal. Tetragonal is simply we can say it's a 4-fold axis. Okay, it must have only one 4-fold axis. So this particular distinction helps us to know from orthorhombic to monoclinic. The next question comes whether it is having any mirror plane or not. If the mirror plane is there, then it is a straightforward answer. Even if it's not having any 2-fold symmetry and it's having only mirror plane, then it is called monoclinic system, and that point group name is M. And it does not have any 6-fold or 3-fold, 4-fold or 2-fold or any mirror plane, then certainly we can say it is from triclinic system, because triclinic system doesn't have any primary symmetry. So that is the indication for triclinic system. So in this manner we able to identify the point groups from the different crystal system. So finally we can use this master key to find a symmetry of different point groups. So this is a master key by using a symmetry logic flow sheet. First we have to check whether does it have 6-fold. If it is yes, then it is hexagonal. If it is not, then we have to check with how many 3-fold. If it is more than one 3-fold, then possibly it may be a cubic system. If it is only one 3-fold, then it is a trigonal or hexagonal. And does it have 4-fold? 4-fold is only representation we will get from the tetragonal. Then even we don't have 6-fold, 3-fold or 4-fold, then you have to check with the 2-fold. If in that case, if the answer is yes, then it is orthorhombic, and if it is no, then we have to check whether there is any other mirror plane is there or not. If other than that, if mirror plane are how many 2-fold axis, then we can check, we can distinguish from orthorhombic and monoclinic. After that, if does have only one mirror plane or not. If the mirror plane is there, then it is a possibility it's a monoclinic. If there is none of this above symmetry is there in the crystal, then it is triclinic system interval. So in this way, the defining symmetry of different system help us to know what is the possible point groups from that respective system. So we can utilize this, and also we can understand the importance of this defining symmetry to find a point groups of the crystal system. Thank you.